Hello. Now we're going to look at solving quadratic equations. And a quadratic is just where we have a highest power of 2 on our x's. So x squared is what we're looking for when we're dealing with a quadratic. The highest power is going to be x squared. And when we're solving, what we're looking for is our quadratic expression, our x squared highest power expression, is going to be equal to 0. And if we think about that in terms of functions or relationships between x and y, that would be looking at where y was equal to 0. So this is what a quadratic function looks like if you graphed out all the points. So if we put in a bunch of different values for x, we would get a curve that looks approximately like this. It looks kind of like a smiley face. So when we have positive quadratics, the number in front of x squared being positive, we end up with something that looks roughly like a smiley face. And where that smiley face cuts the x-axis, where it crosses the x-axis where y is 0, that is called the roots of the quadratic. And when we solve a quadratic, we are finding its roots most of the time. When we get into more advanced questions, we might be doing something slightly different. But for now, we can think about whenever we're solving a quadratic, we are finding its roots, which we mean where is that smiley face crossing the x-axis if we drew out the graph of our quadratic. Now, let's get into practicalities. How do we find these roots where y is equal to 0? If I take this situation here, what we're going to use is the fact that any number at all multiplied by 0 is always equal to 0. So if I had 3 and I multiplied it by 0, I'd get 0. If I had minus a million and I multiplied it by 0, I'd get 0. So I can use that fact in combination with factorizing in order to get solutions to my quadratic. And this is how we do it. If I think about what values of x would make this relationship, this equation, true, well, if x was equal to 0, what would happen? I'd have 0 multiplied by 0 minus 1. That would be the same as 0 multiplied by minus 1. 0 multiplied by minus 1 must be 0. So 0 would equal 0. That would be true. That equation is true. So x is equal to 0 is a solution to this relationship, to this equation. And if x was 1, if x was equal to 1, what would happen? Well, I'd have 1 for x multiplied by 1 minus 1 would be 1 times 1 minus 1 is 0, and 1 multiplied by 0 is 0. And that would also be true. 0 is equal to 0. Those are the only two values of x that I could put in to this equation and get it to work out. That is to say that 0 is equal to 0, to get something that's true. If I put in another value of x, say x is equal to 2, I'd end up with 2 multiplied by 2 minus 1 is 1, so I'd end up with 2 is equal to 0. Now that's not true. So the only two values of x that I can put in are x is equal to 0 and x is equal to 1. So by finding the number, the value of x that makes each of these brackets individually equal to 0, I can find my solutions to my equation. Now, let's put this into practice in a question. I have y is equal to 3x squared plus x is equal to 0. Now I mentioned before factorizing. This is a factorized thing. This was originally x squared minus x is equal to 0. So what I want to do is factorize my quadratics if I can. We'll look at another way of doing this later on, but for right now, I want to be able to factorize my quadratics. So when I'm trying to factorize, what do I always look for first? I always look for common factor first. Common factor comes first. Well, what's the common factor here? It's x. So if I take out a common factor of x, now I have x multiplied by 3x plus 1. I have what I had before. Stuff involving x multiplied together is equal to 0. Well, that means that individually x must be equal to 0, or 3x plus 1 must be equal to 0. And now I can rearrange this. Now I have some work to do. I have to rearrange this to find my value of x that is going to make this equation equal to 0. So I have -1 from both sides to isolate the x. This is just a linear equation like we are used to dealing with. And I get x is equal to -1/3. So these are the roots of the equation. This is a root and this is a root. They're the roots of the equation where y would be equal to 0. And I've drawn them in here where x is equal to 0 and x is equal to -1/3. They're the roots of my quadratic. So let's go to a quadratic trinomial. Now, where I had a common factor of x, I took it out and factorized it. Here I have a common factor of a number. So what I'm going to do is divide out that common factor. Now I can't just divide one side of my equation by a number. I have to do the same thing to the other side, just like I always do with equations. So when I do that, I end up with 3x squared plus 4x minus 7, my apologies, minus 7 is equal to 0. Now, how do I solve my quadratic? Well, again, I factorize. So how do I factorize my quadratic trinomial? I take the coefficient of the x squared and the number on the end, and I multiply the two of them together, and I get -21. Now, what I do is write down all of the factor pairs of -21 and see which one of those pairs adds together to give +4. So let's write down all the factor pairs of -21. Well, I have -1 by 21, or I have -3 by 7, or I could have 1 by -21 and 3 by -7. And which one of those works out? Which one of those multiplies together to give -21 and also adds together to give +4, the coefficient of my x term? Well, I can see -3 plus 7 would add together to give +4, and it also multiplies together to give -21. So that's the pair I want. So what I'm going to do is take that 4x and I'm going to break it up into -3x plus 7x. So I haven't changed this equation. All I've done is rewrote this 4 plus 4x as -3x plus 7x. If I add these two like terms together, I go back to where I started. So I haven't added anything. I haven't changed the equation. Just changed the way it looked to make the factorizing easier. And now that I've done that, I can see I have a common factor to these first two terms and a common factor to the last two terms. So if I take out my common factor of my first two terms, 3x x minus 1, and 7 is my common factor for my second two terms. And now I have x minus 1 is a common factor to both of these terms. So write down my common factor and then write down the stuff that isn't common. And now we're back to where we were before. I have stuff involving x multiplied by stuff involving x is equal to 0. So I have x minus 1 would be equal to 0. I have 3x plus 7 would be equal to 0. These are equations I can solve. They're just linear equations. So I just rearrange them to get x by itself. And I have my answer for my roots. So I have -7, -7. So I get 3x is equal to -7. Divide both sides by 3. I get x is equal to -7 over 3. And these again are my two roots of my equations. These are my two roots. If I put in x is equal to 1 into my original equation, I would get 6 by 1 squared plus 8 by 1 minus 14. That would be 6 plus 8 minus 14. All adds up to 0. So that value of x makes this quadratic equal 0. And minus 7 over 3 works as well, but it's a little bit harder to immediately see. Now, again, visually, that would look like where's my smiley face cutting across the x-axis. Now let's have a look here. Again, common factor comes first. I can see I have a common factor of 2 here, so I am going to divide both sides by 2 because it's not a value of x. I can just divide both sides by 2 to isolate what I'm interested in. And when I do that, I immediately see difference of two squares. So I can write that as x squared minus 3 squared is equal to 0, which would be x plus 3 multiplied by x minus 3 is equal to 0. So I'd have x plus 3 is equal to 0, or x minus 3 is equal to 0. Rearranging, I would have x is equal to minus 3, or x is equal to plus 3. And again, those are the roots. If I sub that into my equation, I would get 0 for my y output. Now, finally, we've got this one here. Again, I can see common factors going on. So I'm going to take out divide out my number common factor. Only divide out number common factors. We would never divide out an x. We didn't divide it out here. We factorized out. But for number common factors, we should divide them out to make the numbers easier to deal with. Now, when I do this here, I know that I'm going to multiply the coefficient of the x squared by the number on the end. Well, I know there's a secret 1 in front of my term here, so I'm going to multiply 1 by 4 is going to give me plus 4. Well, what numbers multiply together to give plus 4? That would be 1 by 4, or 2 by 2, or minus 1 by minus 4, or minus 2 by minus 2. All of those would work out. And which one adds together to give the number in front of the x? Well, it's going to be minus 2 and minus 2. So then I have x squared minus 2x minus 2x plus 4 is equal to 0. And I end up taking out my common factor from the first two and from the second two. And I take out my common factor of x here, and I end up with x minus 2. And here I need to take out a common factor of minus 2 to end up with the same thing in my bracket. So I need to be careful of that in more advanced cases. And I end up with x minus 2 by x minus 2. Well, anything multiplied by itself would just be it squared. So I find then that x minus 2 is equal to 0 is the only valid solution, and rearranging that, I get x is equal to 2 is my only root. Now this is called a repeated root. Now this means that this here is a perfect square. And perfect squares will be quite important in the long run in terms of understanding advanced parts of quadratics. But for right now, if we get a repeated root, so we get only one valid solution, or we get something squared here and we only get one valid solution, visually what that looks like is like the quadratic, the smiley face just bounces off the x-axis. So it just comes down to x is equal to 2, and then it bounces off the x-axis. And it's important to be able to visually see that. So if we ever get a repeated root like this, where we only get one valid solution, where we get something squared, that means that we've got something that's going to bounce off the x-axis, and that is what we need for solving quadratics for now.